Ending it is how you end up breaking it. So hey, and I know we might need to take some time for this. You can sit wherever you want. Again, we can do new groups since we're back from a break. Now, if you like where you sit and who you've been working with, that's totally fine. But if you would like to change group, that's up to you. OP, I love the haircut, but are you ready to go? Do you have a protractor? No. Protractor. Guys, especially as we get further into the year, and normally during the winter I will lose my voice at least once, this box matters. I shouldn't really need to have this stuff in the box, but I do because I teach middle school. But the other things that happen below that, that's what you want to care about. Now, I forgot them today, but as of tomorrow, I believe I have enough coffee cans now that each of your table groupings is going to have a coffee can in the middle of it with highlighters and protractors, or not protractors, highlighters and Post-it notes and colored pencils and like all sorts of other stuff that you might randomly want during math, so then you can just grab it and toss it back right in. Yeah. I've been bugging my boss about that, and I'm hoping soon because we were emailing back and forth about it right before break. Quinn.
When do the coffee cans smell like coffee?
Probably, even though I've washed them. Yeah. I always liked the smell of coffee. I never liked actual coffee till my senior year of college.
I started drinking.
So, 822, just to like wrap this up and put a bow on it to use a holiday expression. What we ended with before break, or before turkey bowling, was talking about inferences from random samples. So I want to remind us of some vocab before we just keep marching onward. What is an inference, or what does it mean to infer? What is an inference, or what does it mean to infer? Savannah?
It means like give a guess.
Yeah, it's not just a guess, though. Yeah, it's like an educated guess, right? It's a guess based off what you know, Braylon. It's a statistical prediction, right? So you take the data that you've collected, and based off what you observe, you then make predictions. Okay, we are going to cycle back to statistics later, like not much later, but we're changing gears right now. Okay, so I wanted to wrap up what we were just doing and like make you understand. Yeah, we're changing. We're like stepping over to a different place now. We're like, you might be like, wait, I thought we were just talking about like robins and weights and like histograms. And we're taking a step away from that for a moment. But realize that means your mastery will have a broader variety of topics on it. Primarily statistics, but then we're going to talk about some geometry. Okay, so we are taking a step over into the geometry world to talk about angles. So I need everybody, no matter who you are, stand up.
I am green.
Then, okay, I guess we are pretty much all facing this way. I'll do that too. Do a 360. Now do a 540.
540.
Ooh, got you thinking this morning.
Wait. I need to calculate this.
Now wait, why was do a 360 really easy, but then 540 everyone's brain like breaks? All right, sit down. What? Wait, hold on. What? So what the heck does that mean? When somebody says do a 360 or he did a 360 or what does that mean? Right? No, what do you mean all the way around?
Like in a circle kind of thing. Entire circle. Okay, so if I have a top and I spin it 360 degrees, and say I made a little dot with a Sharpie in the front, and it's facing this way, and I turn it 360 degrees, the dot's going to be in the same place.
So we have rotated.
Stop in the same place.
We've accomplished nothing, but we've done something.
Yeah.
Is what I hear you saying.
Whole way around. It's like if there's a trick.
All right. You want me to blow your mind real quick for a second?
Sure.
Not a big mind blowing, but okay. So now those of you that are into space, don't yell at me. My drawing will be poor, but bear with me, okay? So here, let's be cute. Here is the sun, right? This is the sun. Now we travel about the sun in what's called an oblong spheroid. So that's not a perfect circle. That's not a perfect circle, but imagine with me that it's pretty darn close to a perfect circle. We are right, let's hypothesize, here in the sun rotation time. That is today, right? November 26, 2018. We will be right back here, same place, referencing the sun, on 11/26/19.
What?
Right? I mean, we do one full rotation of the sun every year. We do one full. The Earth rotates every day, right? Whoop, one around, one around. That's why the sun rises and sets. It doesn't actually go anywhere. The Earth turns. We travel about the sun every. How many days does that take?
365.
Or one quarter if we want to be accurate. So at some point, and there I'm not going to go deep into this because I want to spur some interest but not overteach you guys. 365 and a quarter is really annoying to work with. That's not that fun of a number. But 360 can be cut in half, can be cut in fourth. That's a really nice number. 360 is also divisible by 3 and divisible by 4. What do we have 4 of?
Yes.
What do we have 4 of? That everyone keeps saying it's winter, but it's not. Seasons, right? 360 is also divided by 12, or divisible by 12. What do we have 12 of? Months. Now, here's my only opposition. Do weeks work out nicely? How many weeks are in a year? 52, and some of us don't know that, which is okay. I didn't memorize that for a while. Now here's my suggestion to the world. If instead of 12 months, we had 13 months. Now 360 doesn't perfectly divide by 13, but we could more evenly distribute our weeks instead of having these like awkward 4.5 week months. But that's just my soapbox of we messed up a little bit, but 360 degrees is one full rotation, right? We know that. So just like that in reference, and again, I did not print reference sheets today because there's 3 different pages of paper, and I'm not about to waste that much stuff just to practice our angles. Excuse me. So a 180 degree rotation, and this is where we need to start to represent things. So actually, I don't know why I switched screens. On your paper, draw a circle as best you can. Or if you're bad at drawing circles like me, I'll give you an out. You can trace something like your protractor, or just do this, draw a line out like a ray, and then draw something like that. Right? That is 360 degrees. Now, if we were asked to show a 180 degree angle, that's weird. And this is I need your attention up here. It's probably harder to throw or to show a 180 than it is to show a 360. A 180, I need some more space. If I draw a ray out, a 180 degree rotation is a ray in the opposite direction. So it ends up kind of just looking like a straight line, which is also why a 180 degree angle, and please write this down, is known as a straight angle. L-E, not E-L. What would it be if it was E-L? Angel. I think I had a guardian angel when I was a kid. I'd never met before, stopped at my house to play basketball. He was biking by. I then broke my arm. He went and got help, and he just disappeared. Never saw him. No joke. No, like real story. So if you imagine a little trampoline, like the kinds that you have if you're a gymnast or if you're like a kid with a backyard and your parents don't buy you a big trampoline. So I slam dunked, fell, landed. I was a large child. I landed on my arm and snapped. You know, you have two bones right here. Broke both of them. Just split right up the bones. Never met the kid before and never saw him again. He went and got my family, but they couldn't. They were like far away. Like our house was kind of big, and they were on the porch on the other side of the house. So then another type of angle we have that most of us are probably familiar with. A 90-degree angle, which is known as right angle as opposed to wrong. No, there's no wrong angle.
Are you sure?
I am positive.
What about a 90?
Now then, this gets funky because right, we kind of then have two differing things that derive from a right angle. What are the other two types of angles we often talk about? Queen, give me one.
45.
Well, I mean, we could, if we keep subdividing, we could go to a 45, which is like a nice half right angle, and we use those for like picture frames and things like that. Braylon, what were you thinking of? Yeah, but not right. How else could we describe, like, to kind of get an idea of? Ooh, obtuse, and then acute.
How cute.
Practice. So an acute angle is anything less than 90. And we normally, if it's not part of a shape, put arrows on our rays. And then an obtuse angle, greater Now, greater than 90 then has this kind of caveat. We don't normally go past 180. Once we go past 180, it's kind of too big to deal with, and we don't name it obtuse. It just becomes like a really, like if somebody gave you the angle measure of like 210 degrees. Well, that you don't have to sketch this. A 210 degree angle would look something like this, but this is the angle that we'd be talking about. It's like beyond that straight line angle. So it gets kind of funky in how we would categorize that. We wouldn't normally give it a special name. We would just say it's a 210 degree angle. Yeah.
I would consider this upside down obtuse.
Yeah, and that's the other side of it is like, well, this is obtuse. We know that. It's bigger than 90. So yeah. All right, so those are our main classifications for angles. Any questions about that?
It ranges from 1.
Well, really 0. So if you have 0.0000001 degree,
So like
tiny
0
sliver,
0 to like
89.999999999. Yeah, anything up to 90. So as long as you're less than 90, technically, you're acute.
and if anything right is into like 90 point something.
Yep.
Something.
Yep.
All the way to
179.999. Yep, exactly. Exactly. All right, let's get you guys to practice then. All right, so this angle in your book on 55. So somebody in your class, now do not measure it yet. Do not put your protractor on it. Do not cheat. Mike, are you with me? In 55, your classmate says to you, hey man, I measured this angle, I got 60 degrees. Without using your protractor. I want you to discuss with your team, does 60 degrees sound reasonable for that angle? Take a minute. Now, if, regardless, what would your response to them be? If you have advice to give them, figure out how you would phrase that advice. I'm going to random card for some help. Okay, I need to use these more.
And what? Okay. Could you not?
So when the start screen says that you're going to need a book, why do you decide to not get one until we actually use it? You're not the only, but like a lot of people do that, and I'm just really curious. Like, so if we know we need a book every day, why not get one every day? Now, grab your protractor and figure out what that angle accurately measures using your protractor. And I bet you'll have two different numbers to choose from.
How much are you betting?
Oh, wait. Oh, great.
100 weevils.
Why is so weird? How much are you betting?
It's hard to measure because it's on the book. I'm trying to make it last as possible.
Yep, I know.
Even 60 is going to use just off one day. But it's going good with the actual angle. That's 20 and 10.
Alright, I got my answer.
All right, some technicality on how we work our protractors. Some technicality on how we work our protractors. Number one, the vertex of the angle, which is the dot connecting, oh, I can't grab that, which is the dot connecting, and now I can't. No, I can't. There are two rays. Well, I want the protractor right there. The dot of your angle, the vertex, goes right. Yeah, they're all gone. Goes right at the intersection of your protractor. So right here at the bottom. But before you even do that, there are words on here. Make sure you can read the words. It should say view through. If it says or with, you're reading backwards. And that's not how this works. So flip it over so you can read view through. And then we make sure that vertex is in the middle. Then we have to line up one of them with a 0. And here's where people screw up. So give me your eyes for a second. Wherever you find your 0 through your ray, that's the set of numbers we're using. So, Simon, do you have a suggestion for your classmate that told you that angle looked like it was 60? What would you say to them? Right or wrong? So how would you tell them that you know that they're not right? Oh. So I could look at what seems to be 60, and that's kind of close to my angle, but as Simon said, that's the number on the top. Why is that wrong? Yeah, the 60 would be if we opened up this way from that 0 up. So you have to make sure you're using the right set of numbers based off where do we see our 0. So then if I go up, what is the angle measure of that angle?
114, I'd say.
Yeah, right about 114, 115. So that angle, if you want to try to copy it into your notes, like a sketch of it, is like 114, 115. Any questions on how we get that measurement? Questions on how we get that measurement? So without measuring, now that we're comfortable with the protractor, set it to the side. If you are just estimating, right? No pressure, just estimating. What would you estimate these angles at and why? So I'm going to random card for each different one of these. I want to know why you made the estimate you did, and don't like wait till I call on you and then just randomly guess something because that's lame. Take a minute, check out each of these angles. What would you estimate the degree measure to be and why? Go for it. Your stuff. You got this.
Well, I think that makes me angry.
Three degrees would be tiny.
Alright, I got the angles.
Are we ready or do we want more time? We can accurately estimate. Those are two like contradicting words. There's a lot of variance, right? Because 360 degrees, that leaves a lot of like range. Yeah, you're right. We can make a pretty good estimate though. Like not accurate, but pretty good.
I know.
Yeah, I like it. You're actually up next, you card. So you'll have A if you want. All right, let's bring it back together. I'm hoping we get a couple minutes to work on your homework. Connor, what's your estimate for A and Y?
Probably in the range of 130 to 150.
Okay, and Y?
Well, I know it's more than 90, but less than 180, less than 170, probably 160.
So first thing Connor said, sorry, I want to catch up with you, is we know it's more than 90. Right? So everyone should have recognized that right off the bat. We know it's more than 90. Then Connor's narrowing down his options. We know it's less than 180.
And 170, 160.
And 170, 160, we can kind of inch our way up and say we kind of know where the range would be. And you also compared it to something else, didn't
Yeah,
you?
it's like, well, that's the 110, 120 because of the previous angle.
Ah, he compared with this another angle we knew the size of. So you're going to leave your estimate at like,
140, 130.
yeah, like 130, 140. Sure. Yeah, it also kind of looks like it's halfway between there. So if I draw another straight line out from here, not a very good straight line, but that almost looks like it's straight in the middle, like cutting that in half. So if you used your ruler or something to get a better line there, you'd probably have better luck than me. Over here, you talk. Let's get more people involved. Gwendolyn, what do you think about B?
I think it's 50.
You think it's 50? Why?
Because it looks almost
I like it. It looks about half of a right angle, but a little bit more. I like it. Lizzie, what do you think about C? Oh, how'd you figure that out? Yeah, it's a straight line, right? Now, I think there might be one case ever where a line that looks straight wasn't, like on CPM stuff, but I think they fixed that. If it looks straight, we assume it's straight. Now, it could potentially be like 178, like you might just not be able to see it, but it looks straight, right? So Lizzie's reasoning is good. Looks straight, so it would be 180. And Octavia, what do you think about D?
20 degrees.
What'd you say?
20 degrees.
20? How'd you figure that out?
Mostly because, I don't know, it looks like it's 10 or 20. Doesn't mean it's not that high.
What can I do to like kind of Ooh. What if I start with making this a right angle? We know it's less than 90. Right? But then, what do we cut in half? Not a very good cut in half, but it's close. So that'd be 45. We know it's less than that. If I cut this in half again, not a very good half. Probably about there, maybe. But yeah, so less than 22, right? It looks less than half of 45. So yeah, like 10 to 20, 15 to 20 maybe. Questions? If we try to use some information that we know to figure out these angles, if I tell you B, oh, we may not know this yet, actually.
I know this because it's right up there. It's one of your posters.
So if I tell you B is an equilateral triangle, say it louder. And angles are the same, right? So if I tell you B is equilateral, what would be our estimate or like what we assume is correct for the angle measure there? Quinn?
60 degrees.
Why?
Because 180 divided by 3 equals 60.
If B is equilateral, now I'm saying if because we maybe don't know for sure, that would be 60 degrees at each angle. Now, C actually uses the same rule in a different way. Imagine I take my hexagon in C and I do this with it. What's that triangle look like? An equilateral. What do we say one angle of the equilateral triangle is?
60.
So what do we think that angle of the hexagon is? 120. Because it has 60 degrees right here and 60 degrees right here. This would be 120. Now, here's the other thing we could do. What if I do that? And I said, well, I know together they're how much? Together. If I go from here all the way.
180.
That's 180, right? And then I could work from there and say, well, that looks like 2/3 of the straight angle.
To make an equilateral triangle.
We got multiple ways that we can approximate these things. A, honestly, in my brain, what shape is that? Square. If I go diagonal in a square, how many degrees will that be? 45, because it cuts the 90 in half, right? So if I draw a square in my head, I would assume or approximate that that's probably 45 degrees.
How would you measure the angle on a straight line triangle?
We have to know something. We would need to know more information. I'd rather you guys just spend the last 10 minutes practicing. Let's go ahead and start your homework. Or at this point would be a great moment if you realize that you forgot to turn in your homework before break. It's late, but I have not put it in math yet, so you could save it going in math is missing. It'll still get dinged for being late, but if you never turned it in before break, you should do that. I'm not repeating myself again of what needed turned in. I'm not keeping track of it for you. You should know, or you should be able to check yourself. That's not the pile. I have the pile of work that got turned in separate. You should be. Yes. So guys, here's the deal. If you didn't turn it in, it should be in your binder, and you should know you didn't turn it in. Whether or not you have submitted an assignment should not be a question. This is why we established the organization we did at the beginning of the year.